Good morning. This is Daryl Peterson. I'm the Applications Engineering Manager here at Micro-Measurements, and I'd like to show you one of our newest products. This is one of the strain gauges that's being produced by our advanced sensors line, and this one is a new gauge pattern. It's actually a 3-element rosette that's in a 0.125 inch active gauge length size. We're really excited about these new advanced sensor strain gauges. We've taken a much more modern technological approach to manufacturing the strain gauges. And as you see this package, this is real typical packaging for these gauges, and this is the engineering data that comes with it. If you read it from top to bottom, you'll see that this one is a 350 ohm resistance gauge. It's also got the temperature coefficient of gauge factor. The gauge factor is listed, as well as the transverse sensitivity. And then you have the thermal output coefficients, both in degrees Fahrenheit and degrees Celsius. In this case, it's a 5th order polynomial to represent that thermal output. Here you have the lot number for the alloy or the foil that's used to make the strain gauge. And then you get down here and you've got the item code. This is a part number you could use to order the gauge. Typical packaging here is 5 pieces per package. I've only got one inside of this box as a sample, but typically these come in 5 per box. This is a code associated with when the gauge was manufactured. And then 2 more things you got here. One is a part number. This one is a C4A 06125 PR 350-39P. And what that means, it's a C4A construction, which for us means it's a pre-cabled strain gauge made out of polyimide backing and Constantan foil. The 06 means it's temperature compensated for materials that expand at 6 parts per million per degree Fahrenheit, like steel. The 125 is the active gauge length, so it's 0.125 inches long, or 1/8 of an inch. The PR is the pattern designation. That means it's a 3-element rosette rectangular style. 350 is the resistance. This one is a 350 ohm gauge. And then lastly, you get down to the 39P. That means it's a pre-cabled strain gauge that has 3 conductors that are 9 feet long. So let's take a look at it. So if we open up the box and we reach down inside, here's our sample of the strain gauge, and this is the way that they'll be packaged. And if I reach inside and open it up, you can see that you've got a 3-element rosette. This one has 3 sensitive grids on it, and it's a rectangular style, like I mentioned before, which means that it's got 3 grids on it that are at 45-degree angles to each other. You've got a 3-conductor ribbon style lead wire that's vinyl, that's approximately 9 feet long, and the ends have been partially stripped, so all you have to do is just pull that off and connect it to your instrument. And then if you look closely, this is a 3-element rosette, and the reason that we like to use 3-element rosettes is when we're not sure of direction. From a 3-element rosette, it'll allow you to solve for your maximum and minimum principal strains and direction. And when you compare this gauge to one without the wires, as you can see, you can save a tremendous amount of time purchasing strain gauges that already have the cables on them, because now you don't have the time needed to be able to prep the wires and get them soldered in place. So this really helps to speed up the installation process. So if your application is maybe a structural test of a large steel component, things like maybe bridges or structures that are used to support devices or towers or things like that, you might consider using these types of strain gauges, because they can really make the installation much faster and quite a bit easier, and we also provide them at a very competitive price. If you'd like to find out more information about our C4A Series gauges, please feel free to reach out to us at Applications Engineering. You can get to us through the website at www.micro-measurements.com and click on Contact an Expert, or you can give us a call at 919-365-3800 and just follow the prompts to get to Applications Engineering. Thank you.